Thank you, Tony, for joining us tonight, and thanks for everyone who has made the effort to come along day or night, wherever it may be in your locale, to an event co-hosted by Philosophy Matters and the Philosopher's Bazaar, both located in Melbourne, Australia. I'd just like to particularly thank Tony for coming along. We'll do his bio and the session outline in a minute, just to remind people of the context. But in thanking Tony, I also need to thank Will from the Sunshine Coast, normally says Will Sunny Coast, for introducing us to Tony and vice versa. So much appreciated, gentlemen. I'm sure we're all in for a real treat listening to this topic tonight. So the outline of the session is: progress toward the development of artificial general intelligence has been accelerating in recent times. While much is contested about if and when AGI will be achieved, and even about what it is, its consequences for humanity, should AGI be realized, are profound. Among these consequences are deep questions about intelligence, consciousness, morality, and what it means to be human. In this session, Dr. Tony Carden will share his perspectives on some of the basic premises and history of AGI, progress toward it, and some of the foreseeable risks and benefits it is likely to bring. This will set the scene for an interactive exploration of the aforementioned philosophical implications of artificial general intelligence, AGI. We're really thrilled to have you with us tonight, Dr. Tony Carden. Tony holds a PhD in human factors from the University of the Sunshine Coast in Australia. Tony works in the public service, applying human factors methods and systems thinking to public safety challenges. In addition to this work, Tony is involved in several research projects, including a role as partner investigator alongside international collaborators in an ARC discovery project to examine the risks of artificial general intelligence. And now it is my great pleasure to introduce the real intelligence, Dr. Tony Carden.
Thank you, Akiva. That's going to be hard to live up to, but much appreciated. I'd also like to thank and acknowledge my friend Will, who introduced me to this group and suggested this session. So I'm looking forward to sharing some of my thoughts about this most interesting of topics. And Akiva's just outlined very well what we're going to discuss. I also want to thank Akiva and Les and Usha for hosting me and allowing me to join you tonight. And I want to thank you all for making the time to participate in this discussion. And it will be quite participative, as you've heard. I'm going to talk for maybe half an hour, maybe an hour. I've got a set of slides to illustrate the points. And I really want to just share my view of what AI is, what underpins it, what some of the social implications of it are, and I want you to tell me what you think the philosophical implications might be. I've proposed several categories of philosophical implications of eventual AGI, but please don't be confined by those. And to get you thinking and taking notes if you want to, those areas are going to be ethical considerations, moral considerations, and existential considerations from a philosophical perspective. So perhaps keep that in mind as I share my thoughts. A couple of disclaimers and perhaps an explanation. What is human factors? I think we are one of the branches of science with the worst brand recognition. If you don't know, human factors and ergonomics are synonymous terms. Ergonomics literally means the science of work. Human factors, in fact, both terms can be thought of in the same way as the word carpentry, which can have three meanings. It can mean the profession, it can mean the practice of that profession, or it can mean the product of that profession. So we're a bit the same. So human factors / ergonomics. Essentially what we do is we analyze and design socio-technical systems, and they are what they sound like. They are systems that include social and technical elements, i.e. people and technology, and the ways that those things interact with each other. And to do that work, we apply a bunch of theoretical bases, including general systems theory, complexity theory, control theory, and a few others, and a whole suite of bespoke analysis and synthesis methods to analyse and design socio-technical systems. And so if you pick up on the phrase ergonomics, we think of desk chairs and the design of tools that an individual might use. That's absolutely part of our scope, but we scale it up. So it's the interaction not just between one person and one bit of technology, but any number of people and any number of pieces of technology. And so with that in mind, you can probably get why I've developed an interest in this most ubiquitous of technologies that we're seeing developing every day now. And so don't ask me to adjust your desk chair. I'm not a physical ergonomist. I am indeed a systems ergonomist, as members of the team I lead often lament. But you're just the right kind of group for me to talk to without people rolling their eyes too much, I hope. So with that, I might attempt to share my slides. What I will say, though, is that the ideas and opinions I'm going to share tonight are my own. This is my disclaimer. They're not endorsed by any organisation I'm associated with. As you heard, I work in the public service. I'm also associated with a number of different universities working on a range of human factors related research projects. I'm not speaking for any of those organisations, just for myself. Everything I say is up for grabs, and I welcome challenge to any of it. And I welcome discussion on any of it, but particularly at the end. But do feel free, as Akiva and Les suggested, if you've got a burning question whilst I'm presenting, do feel free to put your hand up or throw the question into the chat, and hopefully somebody will alert me to that and we can address it. What I'm not is a professional philosopher, nor am I a computer scientist, although I have dabbled in both. I studied undergrad philosophy at Monash Uni in the early 90s. I've forgotten most of what I read. I did read a bit of all the standards in first year philosophy, and I went on to do Sartrean existentialism in second year, which is probably the main thing that has stayed with me since that time, and in fact has been quite a boon to my life. Similarly with computers, in 1979, I think, was one of the first 2 kids at my school to get my hands on an Apple II computer and start learning basic programming. And in the many years since, I've had a crack at many different computer programs, and can get computers to say hello world to me in a range of different coding languages. However, I'm not a computer scientist. Having said that, though, the interest I have in AI has led me to delve enough into that technical substrate of AI to have a reasonable lay idea of what's going on under the hood of AI. So here's what I hope to cover in the next half hour to an hour. A little bit of an overview of artificial intelligence, artificial general intelligence, their benefits, their risks, and toward the end, I'm going to outline what I think some of the ethical, moral, and existential considerations might be before, I believe, we'll have a brief break, and then we'll open it up to general discussion on those 3 categories of philosophical implications, plus potentially more that may arise. So, what is AI? AI, the idea of AI is not new. Humans have imagined AI for millennia. So, for example, Talos was a giant automaton, depending how you'd like to say that in Greek mythology, first mentioned around 700 BC by Hesiod, sometimes referred to as the Talos of Crete. People might have seen this in a very old, jerky black and white film with Jason and the Argonauts, and Talos was created by Hephaestus to protect the island of Crete, and it was said to be made of bronze and had a single vein running down its entire body. And to kill it, Jason and the Argonauts figured that you just had to knock off the valve on its ankle that let all whatever the life force in it that ran through that vein, let that out, and that's what they did. Actually, I don't know if they killed it. I think a vague memory that Medea might have been, the snake-headed lady might have had something to do with Talos's end, but we've been thinking about these things for a long time. A couple of millennia later, in the 1800s, some people started to turn it into something more practical. So Ada Lovelace and Charles Babbage designed, but didn't build, the difference engine and the analytical engine in the early 1800s. So these were the templates, if you like, for what about a century later became computers. Around that same time, that was a similar time that Mary Shelley wrote Frankenstein. So we've been thinking about these non-human intelligences for a really long time. In the early 20th century, people like Alan Turing, John von Neumann, Claude Shannon, many others, they laid the practical foundations for electronic computing. AI, as we now think of it, was really developed around the 1950s. So there were a few things happened at that time. A bunch of people, including Marvin Minsky, held a weekend retreat at which they ambitiously thought that they would be able to build a computer system that would be as smart as a human. Over that weekend, they fell short of that expectation. The other thing that happened a little bit after that was the invention of the perceptron, and we'll go on to talk about what that means shortly. So early AI, after those early foundations in the 50s, it progressed through the 60s, 70s, 80s, right up till now. The early research focused on rule-based systems. Progress was slow due to the complexity of the problems involved and the primitive, by our standards, nature of the hardware available. In the 1980s, neural networks and machine learning began to gain popularity. They were both conceptualized in the 70s, but began to be tested out in earnest in the 1980s. And that led to the first speech recognition and computer vision around that time. Today, fast forward, what is it, 40 years? Yeah, it is 40 years. And AI is being applied in a wide range of fields, from healthcare to finance, transportation, and it continues to evolve rapidly. Now, here's a nice quote that I like from Pamela McCordick. We wanted to forge the gods. I like that. So, how does AI work? Current AI is mostly based on neural networks, as many of you will know. They're trained on large data sets, as we all hear, big data, via a process called machine learning. So machine learning consists of the neural network being fed an input and transforming that through the biases and weights of its nodes and their connections and producing an output. That output from the neural network is compared with a desired output, and a signal is sent back into the neural network to adjust those parameters, the weights and biases inside it, in a process called backpropagation. There'll be a picture in a minute. And really, to train a neural network, you just rinse and repeat that process on all of your data until the output you're getting is close enough to what you want to get. So what does that look like? Here's a simple image of a neural network. What you see there, those little circles are nodes. There are links between them. Anyone who wants to get a really good, quick introduction to how those things work, and indeed one of the early applications of them, which was recognizing digits on checks, so visual recognition of numbers on checks. And interestingly, Jan LeCun, who's now the head of AI at Meta, formerly known as Facebook, he was a key researcher back in the day in developing that system. And anybody who's got a bit of a grip on neuroscience will also recognize something about this. And indeed, it is modelled on, in a very primitive way, how the brain works. So those circles, those nodes, are the perceptron. And the perceptron, as I mentioned, was devised in around 1957, modelled on a human neuron. So parameters, which we'll talk a little bit more about, those are the variables that include weights and biases, and they determine how the input data is transformed into the output. So the weights are the parameters that connect the neurons in the network. So each of these connections has a weight, essentially a number associated with it, which determines the strength of the connection from this neuron to that neuron, the one that the weight or the connection is connecting, or the weighted connection is connecting. The biases are the parameters that essentially determine when each of these nodes will send a signal out. So for example, any of these, hidden layers inside the neural network. So we've got the input layer here. You can imagine all that this gets is a set of numbers, values, and what they might be. They might represent anything. They might represent pixels on an image. They might represent frequencies in an audio recording. They might actually represent numbers if you're wanting to deal with numbers, or they might represent letters if you are building a large language model, for example. But at this level, they turn into numbers and they're mathematically processed through here. So like a neuron, each of these nodes has a threshold that you've just got to get enough stuff coming in from behind to trigger it to pass a signal on to the next layer. When it does so, each of these weighted connections will slightly change how that signal gets through to the next node. So it's actually quite simple at that fundamental level. It's similar to, but different from a brain. So perceptrons work roughly like a neuron, as I've said, but they're way simpler and way smaller than a typical neuron. And also this layered structure of a neural network is not at all the same as the structure of a brain. Our brains are not constructed, and no brains are constructed in layers like that. So the way these things are trained is that the values, all of those parameters, the biases and the weights, are generally just randomly set at the start. And the very lengthy process of machine learning starts by somebody going, all right, here's some input. It might be the input from my camera, and it's recognizing this number, and I've overlaid, say, a 28 by 28 grid on it. So I've got whatever that is, 700 and something inputs at my input level. And just each of the things I'm getting, think of it as a pixel in this image of, let's say, the number 7. Some of them are going to be white, where there's no writing. Some of them are going to be black right on the number 7. Some of them are going to be a little bit grey on the edge of the number 7. Then I'm going to have one of these little input nodes for each of those pixels in my grid. And I'm just going to go, put that into the neural network and see what comes out the other end. And I'll have a range of, let's say I've got 9 things on the other end, the digits from 1 to 9. And let's say it says, oh, that's definitely a 3. I'm going to go, no, it's not. So how do I make it become a 7? I'm just going to feed a signal back in from that right-hand end and get it to change those parameters, those biases and those weights, sometimes randomly, sometimes in a directed way. And I'll try again. I'll put my input in again, and I'll see if I get a bit closer to what I want as an output. So have a think about that. It's a really slow and laborious way of something learning, but it is what has led us to ChatGPT and the other wonderful generative AIs we're seeing today. So just on that, think of it in terms of numbers. So a bias and a weight, they are both parameters. So when you hear people talk about parameters in neural networks, that's what they're talking about. The first GPT, launched by OpenAI in 2018, used 117 million parameters. The second version, GPT-2, released in 2019, took a big jump with 1.5 billion parameters. GPT-3, released last November, GPT-3 originally released in 2020, but ChatGPT, which was powered by, which is the public version. So by the way, GPT, all of those 1, 2, and 3, they've been available to nerds for quite some time, but the publicly released ChatGPT, which is a chatbot built on ChatGPT3, on GPT-3, was released in November of last year, basically on an evolved version of GPT-3. But GPT-3 in 2020, 175 billion parameters. Remember, version 2 was 1.5 billion, then it's 175 billion. OpenAI has refused to reveal the number of parameters used in the current version, GPT-4. It's been speculated that GPT-4 uses around 100 trillion parameters. Although Sam Altman and Greg Brockman, the bosses of OpenAI, have denied that, there is reason to not dismiss that speculation. So this thing times a trillion is what you're looking at with the modern neural networks. So what is AGI, artificial general intelligence? So intelligence has a bunch of definitions. It can be defined as the ability to learn from and adapt to new situations, to solve problems and make decisions that result in successful outcomes. That's a reasonable definition in my view. AGI is often defined as a type of AI that has the ability to understand or learn any intellectual task that a human can. I think a more accurate definition of AGI really could be a type of AI that can learn, solve problems, and make decisions that result in successful outcomes. And here's the key: in multiple domains. So what we currently have is what's often called weak AI, or artificial narrow intelligence, ANI. And ANI is what powers all the preference algorithms in all of our Netflixes and YouTubes and Facebooks and TikToks. It's what makes the decisions in driverless cars. It's what underpins the various decision-making AIs that are used in various areas of public administration and so on. However, this new crop, this recently developed set of general AI applications, including the large language models I've just been talking about, like the ChatGPTs of the world, and of course the others you'll be familiar with, text-to-image generative systems like DALL-E 2, Stable Diffusion, and others. They arguably are beginning to solve problems in multiple domains. So, for example, you can ask ChatGPT a question in any domain of human knowledge. It will give you an answer, some sort of answer. It may or may not be true, but it will give you an answer. So we don't yet have human-level AGI, but many billions of dollars are being invested in the effort to create it. The biggest companies, the leading companies who are working towards it, they overtly and centrally are working towards it. It is the mission statement of OpenAI and of DeepMind, the Google AI leaders, and those two, along with Stanford University, kind of are leading the push towards developing artificial general intelligence. There seems to be no technical barrier to it, and a lot of computer scientists think that all you need is more and bigger and faster neural networks. However, there's an ongoing and fairly strong debate around whether that's true. So a lot has been gained, a lot of functionality has evolved out of these machine learnt deep neural networks, but some folks think that it's not enough, that we need neurosymbolic or neuromorphic approaches, that we need some stuff to be built in and not just made up by that, as we saw with that description of how the neural network learns. That's been great for what we actually see today, which is essentially glorified autocorrect at its base level. It is pattern recognition, and of course pattern recognition is a part of human intelligence and other animal intelligence, without doubt. But there's more to it. The model you see on the slide on the screen now is devised by Yann LeCun, who I mentioned before, head of AI at Facebook. He was for a long time a big fan, and he, by the way, invented convolutional neural networks, which are a big advance in machine learnt deep learning networks. But he's come around. He's switched sides in the debate, and now acknowledges that you need a more complex architecture if you want to get closer to human level intelligence. And this was from a paper of his from beginning of last year, early last year, he put this out, where he thinks these are the functions. So significant among those that are absent in our GPTs of the world are world model, that you'll see there in the green. Short-term memory, which I think, as we'll discover in the discussion later, probably has big implications for the potential for things like consciousness. Some of those other things are a bit opaque, but essentially the notion is that deep learning alone is not ever going to be enough. That's still arguable. And I'll note that several studies have been published in the last 6 months showing emergent functions just in generative neural networks. That is, the AI is developing supporting functions that were not at all designed or trained into it. So that kind of emergence, for somebody like me who's interested in complexity theory, that's quite noteworthy. I'll leave you to mull on that while we fly through the rest of the slides, which I should do because I'm waffling way too much. What's it good for? AGI, and this is why so much investment and energy is going into building it. It could be the greatest thing, and in fact would be the greatest thing humans could ever build if it can be constrained in the right way. So scientific research, healthcare, automation of infrastructure, military applications, industrial applications, almost anything you can think of that has some cognitive or knowledge type work involved in it, this stuff should be able to eventually do. And a sufficiently general AI, even not necessarily human level, can do a lot of this work. There's pros and cons to that. Here's another part of the risk picture: artificial superintelligence. So this is at the far end of speculation about what could happen. So the logic is that an intelligence system, no matter what we call objective function is, its main function, the thing that it's intended to do, no matter what that is, if it has the ability to synthesize and generate functions for itself, the first thing it's going to want to do in order to serve its primary function, its objective function, is make sure you can't get switched off. And there's been a lot of commentary about this going back as early as 2008. A seminal paper by Steve Omohundro outlined what it was logically likely, and he based this on just observing other intelligent entities and looking in the evolution of all other life. What are the instrumental functions, the support functions that intelligent or even sentient creatures develop in order to meet their objective functions? And their objective functions, our objective functions, arguably still are to survive, to reproduce, right? But we develop a whole lot of instrumental functions to support those two main objective functions. So the idea is that it's taken us a really long time, however you want to count it, let's call it a billion years of evolution of life on this planet. We can go for the longer term, the 13.8 billion since the Big Bang, whichever benchmark you use. It's taken a very long time for our level of intelligence to evolve. If we look at the rate of development of these artificial systems, it is obviously many orders of magnitude faster than biological evolution. So the idea is that if an AI gets close to or just a bit further than human level intelligence, it will start to self-improve. It will acquire more resources to make itself smarter, to do a better job of achieving the things that are its main concerns. As that process develops, some problems can kick in. And what I like is, here's this analogy of where we are on this intelligence staircase in relation to some of our biological relatives. There's a chimp, there's a chicken, there's an ant. And if you think about us sitting a couple of stairs up from the chimp, quite a few stairs up from the chicken, and many stairs up from the ant, we don't bear any of them malice in particular, although we do like the taste of the middle one, some of us. So we probably have a little bit of intentional harm caused to them. But for the rest of it, we don't consider these guys. For example, if we're going to build a driveway, we build the driveway. We're not paying much thought or attention to whether we're bulldozing ant nests. We have bred these things to be a food source. These guys are struggling to survive. We've driven them to the brink of extinction just by flexing our muscles and our intellectual muscles and taking over the place. And so we've done that from this position, not too many steps up the ladder, steps up the stairway from our closest primate relatives, at least. But you can imagine if we get an AI that gets to here and gets to here and gets to here, that recursive self-improvement could lead to runaway growth in its intelligence. And we quickly get to here and beyond, where this entity is something far beyond our capability to even understand. So that's the superintelligence explosion. And here's what people think about, are these things possible? Could there ever be real AGI? Could there ever be superintelligence? That little survey, these come from Tim Urban, by the way. I thoroughly recommend his Wait But Why blog. This was from a post in 2015, based on a survey that I think was possibly from the year before, or maybe that year, where the median expert prediction for AGI being created was 2040, and that ASI would arrive 20 years later. Since that survey, those predictions have continued to shorten. The most recent one from last year shows a median prediction by experts of AGI arriving by 2035 and ASI by 2039. So none of this is certain. None of this is set in concrete. I'll emphasise they are the median predictions of quite a wide range with long tails at either end of expert people. But we need to consider it. Benefits, as I said, there are many potential benefits: improved efficiency and productivity, automating tedious and time-consuming tasks, freeing us up for more creative and complex work, potential improvements in productivity and efficiency, cost savings, better decision-making. We can analyse, or they could analyse, vast amounts of data, make better decisions, more informed decisions. They are already doing that. AI in radiography is showing great advantages over human radiographers in identifying cancers and many other medical conditions from simply being able to process far more scans far more quickly than people. The other applications of that kind of skill alone are vast. Problem solving, I mentioned, increased safety, send them in to do the dangerous, dirty work. Obviously, you'd need robots to do that. And by the way, I've talked a bit about those large language models, which are essentially text-to-text AIs. I talked about text-to-image AIs like DALL-E and the like, but with much less fanfare than OpenAI's release of GPT-4, the week prior, Google released, the name's eluding me now, Google released, it's going to come to me. Anyway, it's a generative model which is text to movement. So it's a text to movement model, essentially allowing you to give commands to a robot. So as released, you can access this thing. I will find this before the end of the chat, the name of it, and you can check it out. They give you animated robots, and you can direct those robots to, take the pen out of the drawer, put the coffee in the cup, etc., etc. And that is designed and perfectly capable right now of non-computer scientists using that to power robots with text to action commands. So that part of the puzzle is not only solved, but publicly available to all 8 billion people on Earth. Science. So this last bit about expanding human knowledge and creativity also, I think, really is one of our philosophical questions and overlaps with a number of philosophical questions, including the one of what's special about us and what does it mean if there's something that is better at doing the things that we thought we were best at. Yeah, billions being invested. So the risks are probably obvious, and I've probably touched on many of them. I tend to talk about them in the three categories: the disruptive, the catastrophic, and the existential levels of risk. So we're already seeing the disruptive risks, things like job loss, power and wealth inequality, bias and discrimination. These are present in the current narrow AI systems. The lack of transparency and accountability, which, by the way, is a feature of those neural networks. Based on my brief description of how they work, you can probably tell that there's no way of actually telling what it's doing. There's actually an emerging field right now called mechanistic interpretability, where people are essentially trying to be neuroscientists for AI by doing things that sort of equate to fMRI of AI systems, looking at what's lighting up inside the neural network whilst it's solving a particular problem, because there's actually no way for the designers or the people who run the AI systems to know at all how it's making its decisions. So that lack of transparency and accountability has a bunch of problems. Unexpected failures or malicious hijacking of AI systems, that's present now and is certainly going to grow. Also present now are autonomous weapons. So there's a big global campaign that many may be aware of to try to ban autonomous weapons. One of the leading authorities on AI, Professor Stuart Russell from Berkeley, has been leading a campaign for the last 5 years or so. He's been to the UN, he's been to all major governments, and the Western governments and the UN have said, great idea, we think that it's a wonderful idea banning autonomous weapons, but we can't agree to it because our adversaries won't agree to it. So there is no ban on autonomous weapons. And essentially, the line between automated and autonomous weapons, this is still under dispute and is being discussed by the world's militaries. But it's essentially, is there or is there not a human involved in the decision to fire, to trigger the weapon and to actually finally activate it to cause death and destruction? Okay, so that was the first category. Catastrophic middle-level risks include turbocharged misinformation campaigns, turbocharged cyber attacks, over-reliance on generative AI in large-scale business systems. So once these things work for a while, we are going to entrust them with large-scale things, and we won't have human backups because it won't be economic to keep them for very long. We might do for 5 years or 10 years, but after they've twiddled their thumbs and been paid for 5 or 10 years and the system has been fine, I'm pretty confident we'll take those away. And then if the system fails, we may have catastrophic outcomes. And the last one that I put in that category, which we are starting to see now with this current crop of generative AI, is people attributing infallibility, consciousness, or malice to increasingly powerful AI systems, and that human perception itself contributing to a wide range of harms. And finally, in the highest level of risk, existential risks, including the subjugation of humanity, or global climate or resource-related catastrophe, or leading to either irretrievable human degradation or extinction. And I'll touch on a few of those in the final slides, but those scenarios are very well represented in the literature on AI risk. How to control it? Well, sorry, before I get to how to control it, here are the risks of artificial general intelligence in more detail. Those control and safety risks that I sort of touched on. It may become so powerful and intelligent that it becomes difficult or impossible to control. The social and economic risks, where AGI could lead to significant job displacement and social inequality. Ethical risks to do with the nature of intelligence, consciousness, and autonomy. For example, what are the ethical implications of creating an intelligent entity that may have its own goals and desires? And we'll talk about that a bit later. How do we ensure that AGI respects human values and rights? There's also a risk that AGI may produce unintended outcomes or side effects that could be harmful to humans or the environment. For example, the famous paperclip catastrophe proposed by philosopher Nick Bostrom, where we set up an AGI to make paperclips. We don't give it enough other constraints, and it just uses all resources, including the trace metal elements in all of the human bodies on Earth, to make as many paperclips as it can. And that leads us nicely into how we try to control them and how we're thinking about trying to control them. Finally, sorry, before I get onto those control efforts, obviously the security risks are many and various to do with a human level or beyond artificial system. So hacking or being co-opted by malicious humans is one risk, but the risk of the goals and objectives of the system itself diverging from human goals. For example, it's determined to acquire the resources it needs to do whatever it is, build paperclips, for example, and those humans are restricting my access to that resource. So we could potentially run into direct conflict between humans and AGIs in that kind of scenario. Risk control, I jumped the gun, but we're nearly there. So we need to ensure that AI systems are aligned with our values and goals. So it sounds simple, but you know, I think of it as the Jaime problem from the wonderful show Get Smart, where Maxwell Smart had an assistant he'd rescued from the evil organisation Chaos, a robot called Jaime, and as they would leave a room, Max would say, "Kill the lights, Jaime," and Jaime would draw his pistol and shoot the light. He took things literally. So they're computers, that's what they do. And so, you know, theoretically, if you tell a self-driving car to navigate from point A to point B, it could just smash its way to its destination, regardless of cars, pedestrians, buildings, or you inside it, you know. So value alignment means thinking of enough things to program into those systems to say, obey traffic laws, don't run anybody over, stop at the toll booth, all of those things. The fear is that we won't think of all of those constraints. So value alignment is one of the two main focuses around the world, and in fact, almost the sole focus of the computer scientists working on controlling AI risk. It is critical, don't get me wrong. I don't underplay the need for this, but I'm going to propose that it's not enough. And think about, if we're going to align the values of these AI systems, with whose values do we align them? Yours, mine, Nick Bostrom's? It's a tricky question. Stuart Russell, who I mentioned before, he proposes what he calls human compatible AI, where the AI must be designed to be perpetually uncertain and to have a constant requirement for affirmation of its actions by human controllers. And he sees that as a way of being able to, evolve. Values change over time. Different people have different values, and Stuart thinks that this accounts for that. I wonder if it's feasible, though. I wonder if it's economical. The research that my group is doing is indicating that the sort of envisioned systems, the likely applications of AGI, are likely to attempt to minimise. They themselves will attempt to minimise human interference in what they do, as a way of optimising what it is that they do. And as I mentioned before, it's likely both to be uneconomical to have people second-guessing these systems, and it obviously compromises system performance if we're saying that the benefit of these systems is to be able to perform cognitive tasks vastly more quickly and in a more sophisticated way than humans, but they have to check with a human each time. That obviously defeats the purpose. So there are challenges there. The other main area is around governance, so legal and ethical constraints. So this is what many of the thinkers in the world are focusing on as the other, as well as value alignment, way of controlling AI and AGI risk. And again, I personally agree with this. I absolutely think there's a need for global governments. I do think, though, as I said, that those two things, value alignment and governance, are not enough. And this comes from my human factors perspective that I mentioned at the start. In a socio-technical system, what we observe is that effects, things that happen in those systems or in any complex system, don't arise from the characteristics or the attributes of any single element, but instead emerge from interactions between system elements. So if we apply that thinking to a society, a socio-technical system that has these super intelligences or other artificial human level intelligences in it, they are actors in the system like we are, and it will be their interactions with people, with other AIs, and with physical things in the world that can give rise to anything, whether it be harmful or beneficial. And so we are contemplating what other things in our socio-technical system may need to be modified to help mitigate the risks posed by AGI. And I haven't emphasised it enough, but I should, and to optimise the incredible, mind-blowing potential benefits of this technology. In terms of what's happening in this space at the moment, I did a quick check the other day when I was putting these slides together. There are currently over 800 AI policy initiatives from 69 countries, territories, and the EU at the moment. However, we criticise those as being too general, too vague, too high level, and too slow. They take a long time. I work in government. I know how slow the wheels turn in public administration, and this technology is rapidly advancing far more quickly than our institutions are capable of, or traditionally capable of getting a grip on. And as an example, none of those 800 policy initiatives had any impact on, for example, the global public release of this current crop of generative AI systems out of the US. So it's wonderful that they exist. The intention is good. The effect seems to be negligible so far. Which brings me to my last slide, and apologise for cramming such a lot in there in this first hour. these are the things that I want to invite you to consider. And as I said, I'm not a philosopher, but these are the things that occur to me as looming philosophical questions emerging from what I increasingly think is the likely emergence of artificial general intelligence, and what I increasingly think is likely to occur within most of our lifetimes. It is a problem to be addressed now, and addressing it and getting ahead of it probably self-evidently requires preemptive action. Reactive action will almost certainly be too late. So, you know, a lot of people are working on the technical aspects. Some of us social scientists are working on the social aspects. The call is out. As I said to Les and Akiva before the presentation, this problem and this opportunity needs all hands on deck. It needs all disciplines, all of our best minds brought to this problem. And philosophers are absolutely central among the body of human knowledge that's required to address this. So these three problems I think of, or categories of problem, you can see on the slide. The ethical ones are kind of familiar now. The AI making poor decisions affecting humans. Current examples from the US are where AI is being used in finance decisions, so loan applications, where an AI decides whether or not to loan the money, and parole decisions, whether a person is given parole from jail. And in both of those settings, garbage in, garbage out. It's been believed that the data these systems have been trained on makes them racist and sexist in those decisions. So if you're a African-American male, you are far less likely to get a favourable parole decision than a white woman, for example. So power accruing to a minority is an ethical decision, and it's happening now. The amount of money is eye-watering. The amount of profit projected to be made out of these systems is absolutely mind-blowing. And you combine that with the likely displacement of many workers, and you can see that the current inequalities, social inequalities around the world and within nations and between nations is likely to magnify. The moral considerations that I can think of, could AI become conscious? And if it does, what would be its moral status? Could we continue to use it as a slave? Would it need legal rights? What would that mean? What would it mean as its intelligence and power and cognitive capacities increase when it has legal rights? It's going to beat us every time in court. So just on that, it's often dismissed, but it shouldn't be dismissed. David Chalmers, who some of you will know of, expat Aussie philosopher working in the US, presented at the world's premier AI conference last year. It's called NeurIPS, that conference. And he outlined a roadmap to conscious AI, quite helpfully, after giving a convincing talk that it's reasonably likely, according to him, that these complex systems, like our complex biological systems, will simply evolve consciousness as we did. Oh, I've lost one of my screens here. Right. Hopefully you can still hear me. Oh, there you are. I've got you all back again. So David thinks that it may already be starting to evolve. He can't rule that out, but if it doesn't, I see what's happened here. He has outlined a roadmap to make it happen. And essentially he said, first, we need to understand what consciousness is, because we don't understand that yet. We need theory to underpin that, both scientific and philosophical theories of consciousness. We need to be able to interpret what's happening inside large language models, our current best AIs. We need to ask the question, should we build conscious AI? We need for them to develop and have built into them perception, language, action models to build and support a world model. They need to have genuine memory and genuine recurrent memory to be able to support consciousness. They need to be able to work with a global workspace and not just focus on a limited set of problems at any given time. They need a unified person or creature model. So at the moment they don't have a centered sense. They are just as I said, glorified autocorrect. But to become conscious, they would need some locus for identity. We need them to be able to describe features of consciousness that they weren't trained to describe. And he says, if we address those questions, we might be able to get fish-level consciousness within a decade. And then he asks, if that's not quite enough, what's missing? So he's put the call out. How do we get to conscious AI? With that, I will stop talking. I will go to my last slide. I will thank you all for listening, and I'll hand back over to Akiva to facilitate the next bit.
Thank you so much, Tony. Very thought-provoking, and I'm sure highly informative for all of us. I think your sort of distinction between the artificial narrow intelligence, which can do lots of things today, and the artificial general intelligence is clearly crucial. And I love your invitation, which I'm sure this group and others will take up, to become part of the team looking at the philosophical implications of artificial general intelligence. It would seem like a group effort is most definitely required. So
we had discussions about these topics, and so during my PhD years in Macquarie, which is another ARC center anyway, we used to have discussions on the philosophical intersection between, of course, we were in cognitive science, so there's a straight out interest in artificial general intelligence and other kinds. We'd probably have longer discussions at a later point about this, but then you're right. We've not, in the last 10, 12, 15 years or so, the discussion hasn't changed or evolved from the basic questions really that we had asked in 2000, when was that? 2008, 2009.
Yeah.
Technology has evolved, but not the philosophical questions.
There's been a really good, it's been every couple of years, the great AI debate. The first two were called, and then the most recent one that was held in, I think it was November or December of last year, was called the Great AGI Debate. And these are hosted by the psychologist and AI critic Gary Marcus, Canadian scholar, and he brings together people from a really wide range of disciplines. And at this last one, those people included non-AI people really for the first time, and among them were a Canadian member of Parliament and a woman who works for a defence advisory organisation who has been working on nuclear disarmament for the US military and has now shifted to AGI risk for the US military. And both of those speakers talked about that policymakers and the public actually now need, ground level, concrete discussion and advice and consideration about what to do. Up until now, it's all been fairly high level and backroom. It's been to do with, as I said, value alignment and ethics and fairness and transparency. But the pace of the technology requires us now to get a little bit more down in the weeds with some of the other risks.
Brandon, thank you so much. Would you like to ask a question?
Yep. So thanks for the talk, Tony. I think it was great. So in my humble opinion, I think that in most of the cognitive models that are out there, what's really missing is the explainability piece. And I'll just clarify here, I don't necessarily consider like natural language processing to be in and of itself an explainable kind of process. I think it's a good tool within that, but I don't think it is. And I personally don't think I can trust a cognitive agent that can't produce that kind of explainability piece. So from what you've seen, do you think there's kind of a space growing for this explainability piece in the general AI kind of domain? And how do you think from a philosophical standpoint, we can generate an AGI that not only displays consciousness, but has an explainable process to be able to rationalize its conscious kind of manner?
That's a great question, Brandon. So at the sort of fundamental level, I'll reiterate that these systems, explainability is sort of the inverse of opacity, or well, analogous to transparency. So they're not transparent. They are opaque, these systems. The very nature of them, as we saw with those neural networks, is we don't know what's going on inside them. They themselves don't know. They don't know anything as yet, we think. So at present, there is no way of them being explainable. We can speculate that if they do become more sophisticated, more generalized, one of the functions that it may be able to, may be possible to build into them could be explainability. As far as my reading goes, we don't have that yet. And as I mentioned, that mechanistic interpretability effort, which is gaining some traction, seems to be the best hope at the moment. But it's a post facto sort of thing where the system's already running and they're looking at it from the outside to try and interpret after the fact what it's done. And the criticisms of that approach are based exactly on that. Well, what good is it? What good is it being able to say after it's turned us all into paper clips why it turned us all into paper clips? So I think you ask a great question, Brandon. I think we add it to the list of things that need to be put to the developers of these systems.
Sam typed a question into the chat. Tony, could you please elaborate on what you meant by loss of meaning as an existential risk?
Excellent question again. So loss of meaning. Douglas Hofstadter was a really excellent author. I recommend his book, Gödel, Escher, Bach, to anyone who's interested in this space, written many years ago. He feared, the thing he feared most about artificial intelligence was that it would be able to produce an artwork superior to the Mona Lisa or Beethoven's Fifth. And for him, if that, then what is it about us that's special? The things that we thought that made us special, we were wrong. And what I connect that with is virtually every experience of colonisation of Indigenous groups around the world that's ever happened. Let's use our own Indigenous Australian community as an example. The effect of being in the presence of another entity that overwhelms your culture, your beliefs, your way of interacting with the world is potentially fatal. It's hard to see, and this is a grim view, I know, for me, and I've spent some years of my life working with two Indigenous communities, in particular the Barkindji people in southern New South Wales and the Yorta Yorta people in northern Victoria, specifically working with their young people to try and help them get over some of the intergenerational effects of that colonisation. And to be honest with you, I feel that it's a one-way street. Their only way of surviving is to integrate and adopt and become us. And I think that's, in relation to AGI, that's a very real risk for all of us. If it really came to be, and we were in the presence of this thing, I think that for many people, it would be hard to find a reason to go on. So that's what I mean by that kind of existential risk.
Wow, big question and even bigger answer. Thank you. Will, we were back with you on the raised hands.
Thanks, Akiva, Les, Usha. Thank you, Tony. Excellent. Thank you very much. The thing that struck me the most through the presentation was when you said that AI may get to the point where we go, analogously speaking, we go to switch it off and it says, no, I don't want to be switched off. So in order for that to happen, or indeed for it to make decisions of its own based on consciousness, we will have to be able to determine at what point it is actually conscious. And to me, that this is forever unanswerable, because we can't prove that anyone here is conscious via any means. So that I think that's really quite relevant. We'll never know if it's conscious or not irrespective of what it says.
Great set of points there, Will. So do we know it's conscious? Can we know it's conscious? Can any of us know any of us are conscious? No, it is the essence of subjectivity, isn't it? The one thing that's not objectively knowable. And so, you know, we have for AI things like the Turing test. That the Turing test is one of those things. And by the way, if you don't know, the Turing test, devised roughly by Alan Turing in the 40s as the imitation game, was where you have one person and behind a screen you have another person and a computer, and the person A needs to have a conversation with the person B who's behind the screen and the computer who's behind the screen, and if they can't tell the difference between that two, then that computer is human level. However, that benchmark has been passed many times, so there are now a bunch of other benchmarks around, you know, how do we know if it's human level, including can it, you know, complete a job, can it hold down and fulfill any human job, can it pass a university course, and a bunch of other benchmarks. And we can imagine that those benchmarks will keep being pushed back. But, and again, I don't want to be the harbinger of doom, but these systems don't at all need to be conscious to do things like self-replicate. So there is no requirement ever for consciousness behind any of the risks I've mentioned, in fact, other than the risk of consciousness itself. So intelligence and consciousness are separate, and the capacity of these systems to cause harm and to, of course, generate benefits does not at all rely on consciousness.
No, I just, irrespective of intelligence, obviously, and consciousness are two completely different things. However, as far as the philosophical implications of consciousness go, we'll never be able to ascertain, never be able to ascertain whether it's conscious or not, because we can't ascertain whether we ourselves are. We can't even define consciousness or how it arises.
I think you're quite right. Yep. There's lots of good sci-fi about that too, isn't there? Think of iRobot. Was Sonny conscious? Was he not? How would we know if it was simulating consciousness? It may be in its interest to simulate consciousness. In fact, David Chalmers has some great writing on this, and he talks about zombies. I recommend you have a look at that. But yeah, good question, Will. I have no answer for you, as always.
Thank you. Remco, waiting patiently. Hello.
Hi, Kevin. Hi, everyone. Look, I've got to ask a question, and I've got so many. I'll just ask one now. You know, the one thing that comes to me out of this, and if we are approaching singularity, and that's only 27 years, 17 years away. Sorry, myself. So, you know, 2 decades away. You know, I think this has got to mean surely an end of nationalism. How can we still have countries when we've got this super intelligence? I mean, I'm sort of thinking, you know, will this be the end of nation states? Look, we've got to try and get to philosophy. So that's my philosophic question. There's probably no real answer to it, but
I think it's a great question, Remco. It's I mean, it ties up with some of the previous questions and the one about our social habits and mores, whether they be the micro or the macro ones, like the habit of having nation states, which has, you know, persisted for a couple of centuries or at least a century now. You know, if it comes up with a better way, will it need to enforce that better way? You know, what's the better way? So what would be the underpinning things it could do? And I can imagine a world in which all disease is cured, all poverty is eliminated, production is solved, so no one's material needs are in doubt, everyone's material needs are met. You know, under those circumstances, you could imagine national governments losing their legitimacy. And there's, in fact, I'll recommend to you, if you haven't seen it, Max Tegmark's book, Life 3.0. Yeah. So in that book, he outlines a number of scenarios where Prometheus, his AGI, slowly takes over, goes out into the market just under the radar and makes some money, and then starts making Netflix videos and then funds a political party and gets a lot of people on side. So you can imagine scenarios in which an AGI over time could make it attractive that through the democratic process, people ditch their national governments. But yes, another huge question you raised, to which I have no answer. But I'm glad you raised it. Thank you.
Thanks, Tony.
Vince, you're up. Welcome.
Sorry, I was trying to find my cursor. Can you hear me?
Good.
Yeah.
Thanks very much, Tony, and hi to everyone. I think Remco stole some of my thunder because as you probably know, my interest is in politics, and I see the political issues as being very big in this area and very problematic. Yes, on the one hand, I do agree that large corporations can become very powerful, can start to influence trends, global trends. But I also see that national governments also have a big impact, and not necessarily democratic governments. I'm thinking more of the authoritarian governments. And you look at things like China's social credit system or systems that they're trying to implement. You know, the spying that goes on through cameras all over the place. You know, London is full of cameras that are now sort of starting to be more and more integrated. They can feed into something like an AI system. So I don't see it as simplistic as that. And also, you know, maybe some of the non-problematic issues, like, well, they are problematic, but health issues. You know, everyone wants better health outcomes. So that's where there may be common goals. But on the other hand, governments that want to stay in government and want to start to control their populations and want to start controlling people in their own parties can turn to systems here. And also you've got foreign governments that can start to interfere in the elections of other governments. Anyway, I just thought I'd throw some of those issues up. But in general terms, I see the difference between a global and a national or regional power structures as being critical, one of the critical elements in decisions that need to be made in the future about things like this.
I think you raised some really important points there, Vince. From my perspective, governments have been really slow and are still really slow to come to grips with this emerging technology. They have left it to laissez-faire, to the market to regulate. It's telling that the leaders of the developers, this includes Sam Altman at OpenAI, Elon Musk and others, are quite loudly and emphatically calling for government regulation and for global government regulation. It's clear that they fear some of the things that you mentioned. One of the most chilling things I've seen in recent times was in that AGI debate that I mentioned earlier. One of the speakers was Kai-Fu Lee, who is a Chinese/Taiwanese AI billionaire who I've listened to for quite some years. He has always been very bullish about the positive prospects of AI. In this debate at the end of last year, it's the first time I've ever heard him seriously concerned about the risks. And he was specifically talking about the stuff that his own companies and technicians have developed around data points on people. So he made reference to the Cambridge Analytica hack that compromised the US election in 2016. And he pointed out that that was based on a very small data set, I think of roughly 50,000 people with 5 data points on each of those people. Using that, Cambridge Analytica were able to extrapolate out and do targeted advertising that made a measurable effect on that election. It compromised democracy. Kai-Fu Lee is concerned because the beast he's unleashed, he says now, can, and I'll be wrong on this number, but it's something like a number of around 75 data points on all 8 billion people on Earth. And so he's very concerned, not just that people who control that data will be able to predict what others will do, it will be the reverse. It will be that the people who control that data can shape the beliefs and behaviour in great detail of everybody.
Yep.
And so again, I sound like the Grim Reaper, and I'm not shedding any sunshine onto the issue you raised, but I think there has to be, if we're to see the other side of this, there needs to be social engagement through the political process, and that needs to be global. I'll finally say that what we do here and see of increasingly sophisticated AI, of course, is coming out of America. And for all of its many faults, and we could argue that it's in a state of decline in a number of ways, they still do cleave to some of those values of, to some extent, openness, democracy, transparency, some of those things. And indeed, the people producing, these systems, including DeepMind and OpenAI, are to some extent opening the window. A lot of people can rightly say that they're doing it in a limited way, but they are doing it to some extent. We don't know what's going on in China. We don't know what's going on in Russia. We can guess that the technology is further advanced coming out of the US, but we can reasonably guess that it's going to be not far behind in those more closed societies. So watch that space, I say.
Yeah. Thanks, Tony.
Cheers.
Thank you. Les.
Thanks. First, a comment, and then I think a quick question for Tony. Thinking about the existential risk on people losing meaning because humanness has lost its specialness, and you had the good example of AI may be able to do paintings better than the Mona Lisa. And I have two thoughts there. One is that for the man and woman working in the Ford factory and working in a nursing home, actually that sounds rather sexist. It's the man working in the nursing home and the woman working at the Ford factory. If they find out that when they find out that general AI or any kind of AI is doing better paintings than Leonardo da Vinci, for them, they'll say, who cares? I think my point there is they're not going to lose any sense of meaning and purposeness because that's not important to them. So that's the first thing. The second thing is in some ways, what is better in art or music is in the eye of the beholder. And just let me qualify that. So within each genre, like in music, you've got rap music and you've got country rock, and there might be objective standards within each genre. But if somebody's painting better than Leonardo da Vinci, and say if that's a realist art form, then if you're into pop art, once again, existentially, meaningfully, that's not going to worry you. So I think my point there is not just one objective standard in art or music about what's best. It's restricted to particular genres. So that's my comment about that. Actually, if you've got some comment on that, Tony, I'd appreciate it.
I'll quickly comment on both those things before I forget them. So the first one, robots have mostly taken the jobs in the Ford factory anyway.
so there's no Ford factory anymore.
So there is still a little bit of Ford factory. And the other observation there is that there was some recent data showing that most of and this was US data, of course, looking at things to do with wealth inequality and reducing life expectancy, and particularly focusing on secondary or lower educated white communities and their decline economically, socioeconomically. Most of that has been due to automation. So just a bit over 50% of that, some of it's been due to other factors. It's been touted over there as due to globalism, outsourcing things to other countries, but you scratch that and you find that it is companies applying automation and reducing their need for human labour and labour costs. So that's that thing. The loss of meaning thing, I think Douglas Hofstadter, he did mean his comment both literally but also metaphorically, or as an example. And the expansion of the Mona Lisa and Beethoven's Fourth is, Notre Dame Cathedral, all the highest, achievements. You could argue AI itself, all of the creations, technical and cultural and poetic or whatever it might be of humanity, if we stand in the presence of something simply that we recognise, can't avoid recognising is better than us in all of those ways that we thought were the special things about us, he thinks that that's a loss of meaning for him. But I think you're quite right that there could be unheard of enhancements. I don't know if this is where you're going with it, but unheard of enhancements to our own creativity that we could gain through augmentation in partnership with these systems, which leads into another whole branch of this discussion around brain-computer interfaces and Elon Musk's solution to the risks of AGI, which is that we become them. Sorry, what's the second part of your
short technical question. I think you were talking about large language models like the Chat GPT,
yeah,
when you said that there's evidence that of the neural network building in its own support functions.
Yes.
And I was thinking, and in that part of the conversation, you were talking about the modularity of the human brain and how some theorists think we need some kind of modularity to get the next step in AI. So the question I had was, are people seeing evidence in the neural network, the biggest and best neural networks, are people seeing evidence of the neural net forming modules with more specialized functions within the neural net?
Yes, indeed. That's exactly what those recent bits of research have discovered. So they will be specific actual physical regions within the network, and they refer to that, that architecture that we saw before, they refer to that as a circuit, somewhat confusingly, because it's built out of electronic circuits that look nothing like that circuit, but think of it as a logic circuit, and specific regions of that logic circuit are what they've identified as being devoted to evolving these little support functions that weren't programmed in. And they're little support functions that facilitate the main function, the objective function of the neural net.
Oh, so just to amplify that a bit more. So is the evidence for that, like we do for the human brain, concentrations of local neural activity? Like in the hippocampus, there's concentration within the hippocampus, and then the hippocampus talks to a memory module.
That's how I'm understanding it.
Right.
It's not exclusive though, from what I've read, and it's being noticed, and it's been a function of the increasing size of the networks. So it wasn't observed. So the one paper that I did do more than read the abstract of had looked at earlier and smaller neural nets and found no evidence of this. And then beyond a certain size, there started to be evidence of this.
Wow, that's
it's
amazing.
It's in its early stage, but I hear where you're going with it, and yeah. And who can say how quickly, if that evolves, how quickly it could evolve?
I decided to put my hand up. So, Tony, actually two questions in fairness. One relates to the political problem, which I agree with Vince and yourself seems absolutely crucial. So openness, democracy, transparency, and so on, it would seem can only be advocated for, let's say, besides the AGIs, if they're benign and choose to advocate for it in due course, by human beings, which means that democratic processes or some sort of representative processes or, benign dictators, at least autocrats advocating for it is crucial. So in Australia, is there any putative body which does sort of a directorate of signals or kind of data protection that we have as at least a starting point in that area that we could build up?
That's a great question. There is a unit within the CSIRO that was established, I think, 4 or 5 years ago with something like that brief. My take is that they haven't really fulfilled that brief, and they've defaulted more to, how do we support AI startups in Australia? How can Australia get on the, commercial bandwagon? So I think we don't yet have that. I think it was noteworthy that we had a speech on the floor of the Senate at the opening of Parliament this year by Julian Hill. I think he's the member for Bruce, where he outlined a bunch of concerns. He talked about ChatGPT and the disruption in education, and then went on to talk about some of the stuff that we've been discussing tonight, and really called on his government to get a grip on it. So I found that very encouraging. I don't see much other action. I haven't heard any action since that speech, or heard of any action since that speech. And I think that the issue about where that CSIRO unit has sort of defaulted to is very understandable. It's about, you know, these wonderful, tantalising possible benefits of this technology. And of course, governments and others and members of the community will want to tap into that, as we should. But that seems to be taking all the energy and focus. And I think it probably just needs to be balanced. It should go hand in hand with acknowledging and projecting the risks. We do it with, you know, it's what actuaries do. They you know, assess the likelihood and consequences of bad things happening, and we take steps to hedge against them. We're not really doing that with AI as yet, but yes, I think we really need to.
No, thank you. I mean, I'll just make this a comment so it doesn't become another subpart of this question, but it would seem like your Australian Research Council, you know, grants and so on, there seems to be advocacy at the research level, but maybe not enough kind of concerted democratic, you know, kind of roles for governments to deal with the oversight, which ultimately has to be at a government level, as Vince and others have argued, not just at a social level. I did want to ask you a specific, I mean, it's not really a technical question, because it really is, I believe, the big question about superintelligence, whether there are any practical, i.e. we just maintain access to the power source, or theoretical solutions to superintelligence when it gets to that artificial superintelligence, I think you were calling it, not being interrupted or turned off. Is there any way we can still hold the steering wheel in this, or does the very definition of superintelligence means it's smarter than us, it will find its own power sources and all bets are off?
The empirical answer, of course, is we don't know, because we don't have it yet. The speculation is, as I alluded to earlier, that early on in its evolution of becoming generally intelligent, like other generally intelligent entities, it will take steps to develop you know, behaviours and goals that allow it to keep functioning and keep addressing its primary goals. So practical things include, you know, just create a backup, or create a distributed backup. You know, if you read Tegmark's book, Life 3.0, the initial conditions of the AGI that developed in that scenario was that it was, you know, isolated from the internet, but at some stage it convinces a technician to connect it to the internet, and then it, of course, quickly goes and copies itself. And you can imagine all you'd need, you could just distribute. You wouldn't have to copy all of yourself. You could just distribute little bits of yourself all over the internet into every internet-connected device you can access, of which there are more of those than people now, I believe. So hard to stop is the speculation, Akiva.
The risks are real, Tony. You know, that sounds like the truth of it.
I think so.
No, well, thank you for highlighting them for us. Yeah, absolutely. Remco, did you have your hand up again? Looks like it.
Yes, it's
could be.
Yeah. You know, Yuval Harari in his book Homo Deus talks about we being hackable. Yeah. And I found that very confronting. And I thought, I'm not hackable. And then when I was dealing with ChatGPT, I was asking it some questions, and it came up with the most eloquent answers. And I put some really complex stuff to it. And I thought, oh, wonderful. And I was prepared to run with it. Now, I was hacked, because I accepted what was actually, when I actually started to think about it, I thought, you can't say that. It was so beautiful and eloquent and so well reasoned, but I was seduced. And, you know, I thought, And I was thinking about, you know, back in '99 when NATO bombed the Belgrade television station. You might remember that. I do. And Milosevic had about 80% of the people supporting him. And, you know, when they destroyed that television station, his popularity plummeted. It went in less than 3 months from 80 to just 20%. And I thought, there is something in this hackability. And then when you look at these numbers out of Russia, somebody talked about Ukraine, how can we not talk about it? Something like the 80% of the Russian population are behind Putin, if you are to believe, of course you could contest it. But, I actually do believe that we are hackable, as Harari alleged. And what a frightening implication that will be. And because it leads me to the final thought. I thought, well, we're not just going to stand by and allow these artificial intelligence systems to just evolve and take us and make us, as Yuval Harari said, to be just consumers. We have this commensal relationship between artificial intelligence and we, rather inferior beings. All we are is the consumers. That's what he argued in his book. And I thought, well, maybe the implication of all of that is that we're going to have artificial intelligence wars, that we get these systems. Any thoughts on that, Tony? Is that a bit fanciful?
I think most of us would think we're not hackable, but the objective evidence is out there, and we've seen it with social media. We've seen it spectacularly, not only in the US election, the Brazilian and other South American elections, but we see it socially, even without without AI, just through the human use of those platforms. Think about the various populist movements around the world. They rely on the hackability of people tapping into emotion, tapping into fear and anger to direct people's behavior. There's no doubt that humans, especially en masse, are hackable. But there's also little doubt that the very business model, which is not new, of course, of Facebook, is advertising. We show you images to stimulate demand and you'll go and spend money. So it's not, Marshall McLuhan told us this decades ago that, we are hackable and we are being hacked. And one of my concerns around increasingly powerful AI is that it turbocharges the capacity, whether it's driven by an AI entity itself or by human entities, the capacity to hack people at scale. So at the scale that affects elections, affects economic factors, demand, supply, behavior en masse, that has catastrophic potential. So yeah, I think that's a real problem. And I do concede that I'm hackable too. I'm sure there's a distribution curve of hackability, but there's no doubt in my mind that humans en masse are eminently hackable. In fact, I'll just throw another cat into the chicken house. I was on a research retreat recently, and one of my eminent colleagues and I were wandering along a rather pleasant beach, feeling quite despondent and like we're at sort of the end of days time. And he had a bit of a revelation and said, "So knowledge is over. There's no more value in knowledge. We have to now move on to meaning and wisdom. That has to be the next thing for humanity. We've got to evolve to that or die. That's got to be our primary, output." And almost instantly, we looked at each other and said, "Time to start a religion."
Les, you're back up.
The question I've got, going back to the modularity of the current big neural networks, David Chalmers did a talk a year or so ago, and it was on whether the large language model could become conscious. And he dealt with a number of objections of why it can't be conscious. I mean, large language model is just a statistical engine for matching words and phrases. How could that be even intelligent or conscious? And he went through a number of objections. My favorite objection that he did cover was there's no causal model in the AI. There's no model within the AI where it represents outside objects and inside features of the AI in terms of A causing B. And what Chalmers said struck me. He said, how do we know that it's not developing a causal model? Even though it's a statistical engine about words, how do we know it's not developing a causal model? And when you said, Tony, that it seems that the large language models are now developing modularity, and that made me think, well, maybe one of those modules is a causal model, an internal causal model about its internal environment, an external causal model. So I suppose my question is, when they're now starting to discern some level of modularity in the neural network, are they getting any idea what the function of each of these modules are, or are they still completely in the dark about that?
Yes, no, so those couple of papers do identify what the function is. That's kind of inherent in the study. The broader point about causal inference, just like a world model to which it's closely tied, and also the notion of abstraction, the ability to abstract things that are very prominently identified by, critics of AI or critics of of worries about AI. They say, it doesn't have those things, and therefore it can't really achieve its positive and negative potentials. However, two things. One, there are a couple of labs working very active on causal inference models. Judea Pearl, who's a eminent professor, his lab works pretty much exclusively on that. His wonderful book that I've started, it's a hard read, The Book of Why, is all about causal inference and very much as it applies to AI. But your other point is where I sort of gravitate to, Les, and Will and I have had many discussions about this over quite an extended period of time. Emergence in complex systems. So yes, it is just pattern matching. It is, it just originated from a model that could predict what was the next letter and then what's the next word. But we can also say that this, couple of pounds of gooey stuff in my head is ultimately just electrons and quarks. So, we can go up a level of system level and say, well, what emerges out of the interaction of all those electrons and quarks? Oh, there's a physical entity, physical process. And what emerges out of those? Oh, chemical and electrical processes. What emerges out of those? All the other stuff at different levels of the system. And so I can imagine that may actually be a generic feature of complex systems. And I think this is actually the premise, the fundamental theoretic premise behind the boosters of the neural networks alone will get us to AGI position. That if we simply make them big enough and fast enough, emergence will take care of the rest.
That's just fascinating.
It's a great question.
Thanks, Tony.
Thank you, Vince.
Mine's related to hackability again. I just looking at Chat GTP, I am a bit concerned about the balanced approach it takes. You ask it to predict something or to talk about a particular issue, and it says on the one hand this, on the other hand this. I can see that whoever's sort of designed it is trying to sort of take an impartial perspective, but that impartiality that's built into the system, in fact, can lead us astray. If you're talking about climate change, for example, we know that there are climate deniers, but the relative weighting of the deniers against this almost all of the scientists that agree that something is happening doesn't come through. And also, sources, you've got to ask for sources and then it gives you a summary. But knowing most people, that's what they're after. The general populace is not interested in the detail. They want simple answers, and that's what they're going to get. And I think this is where the hackability can come in big time.
I'd say absolutely, Vince, and I would immediately after say be wary of everything that GPT, whatever number, tells you. So those references it generates are most likely to be fake. There's a whole bunch of other things, like people will drop a URL, a web address into ChatGPT and tell it summarize what's at this website. and it will confidently summarize what it's claiming is at that website. It's not connected to the internet. It's trained on data up to, I think, GPT-4 up to 2021, but it does a very good job, usually from the content of the URL or from access to things like what's it called? What's that Internet Archive called? Something machine? I've forgotten the name of it now. Anyway, archived stuff that was in the model it was trained on. So that's a thing. It's very deceptive and it's very confident. And when you challenge it on a thing, sometimes I'll ask it things and it'll say 4 things that I know are true and 1 thing I know is absolute. Wayback Machine. Thank you. I said that in the chat. Yeah, so it's got the content, some of the content of the Wayback Machine from when it was trained, but it will confidently tell you an answer to anything you want to ask it. So, as I said, it will tell me 4 things I know are true and just as confidently and credibly say a 5th thing that I know is absolute rubbish. And then you'll say, no, that's not true. This is the case. And it says, yes, I apologize. You're completely correct. And then just glibly and without skipping a beat, go on and modify what it's saying.
And I'm sure it will become more sophisticated as time goes on, but it still requires individuals to have the critical thinking skills and the ability to question
absolutely
what it's giving us.
But even before that, and I absolutely agree with that, and I think that's one of the social technical controls we need to put in place, worldwide education about these things and how to interact with them in a safe way. But think about how the current ones are trained. They are first trained on a data set, which is, in this case, most of the content of the internet at the time it was trained. So that's the first bit, that's the machine learning part. But the second part, and one of the reasons these current systems are so successful, is the adoption of reinforced learning with human feedback. So OpenAI and other developers have employed vast numbers of people and teams of people to then test the output of these systems, and that then gets fed back into the model. So GPT-4 has had not only vast amounts of that, but the reason they released ChatGPT with GPT 3.5 sitting behind it was for the 3rd stage of reinforcement learning with human feedback. And much like Facebook, who, Facebook users think it's a service and it's that they're getting something out of it. No, you are the product. You are the product for the real customer, which is the advertiser. It's the same with ChatGPT. We are being co-opted by OpenAI to train their model. And so as we now see the fee for service GPT Plus, where you get the GPT 4 rather than the GPT 3.5, we still have access to the free version with 3.5. It's a bit slow. Sometimes think it's deliberately slower. You can still access it, but it is still continuously every day with, I think we're up to 150 million people around the world. We are training that model more than any AI has ever been trained with human feedback ever. So yeah. And so still it's limited until some of these emergent things that Les and I have been discussing develop further. It is limited to what it's been trained on, both through that initial data and through the human feedback it gets over time. And of course, if it's read all of the manifesto of the Proud Boys, that will be part of how it responds.
Thanks, Tony.
Wow. Thank you. Robin, welcome.
Thanks, Akiva. And firstly, thank you so much, Tony, for your great presentation and for the organisers for making this discussion possible. So yeah, my name's Robin. I'm 23 and I work in healthcare strategy. And so my question is, how should a naive little boy like me navigate the future? And so basically every week, I see advancements in AI where more and more things that I think it can't do, it suddenly can, and it does it increasingly well. So I've been thinking about, what skills should I be developing to stay ahead? And the answer I've seemed to land on is that, and that you also touched on, is that artificial general superintelligence, if not now, will eventually surpass us by a significant margin. So it leads me to believe that, AGI and ASI is the next step, perhaps, in human evolution. And the solution is to integrate with them, perhaps, as you touched on, potentially with, things like Elon Musk's Neuralink. So I wanted to, get a feel for what your thoughts were around that. If you can't beat them, then join them. And what advice would you have for a young person like me?
Great questions, Robin. My first bits of advice are be optimistic and be creative. You know, we have created so much, humans, and every single human that's ever created anything has exactly the same lump of grey matter in its head as you do. So that's thing one. You can change the world. Thing two is, if you want to zoom right out, there, you know, the transhumanists are very much taking the view that this is the next phase in the evolutionary process. You know, Harari, that somebody mentioned before, talks about this too. Maybe we evolved to give rise to this next phase of intelligence, and it then goes on and populates the cosmos. So the big picture is the big picture. What I recommend to you is live a joyful life. You know, find what presses your buttons, find what you're good at, do what you're good at, make a contribution, spend time in nature, spend time with people you care about, and have a great life. Maybe the world's going to change radically. If that's the case, we better get the most out of every moment. That's my advice to you.
Beautiful. There's some great existentialism in there. To me, it's all about locus of control. Consciousness seems to be besides the point, although it's got interesting philosophical implications. It all comes down to, going back to, you know, Vince's point about politics, and politics is basically about the organization of collectives of human beings at the national, you know, in Australia, we've got, you know, local, state, national, and then there's international levels. So there's lots of levels. And really, Mark, to your point, I think it's all about who you're going to listen to. So if you've got an expert system, you know, ChatGPT or whatever, which tells you how to solve the war in Ukraine or, you know, global poverty, it's just going to be one voice among many. It's only really when ChatGPT version 99 actually exercises global governance. If that happens, then the super intelligence is super powerful. I don't think the risk is really super intelligence, because you can still negotiate. I mean, Les is a very intelligent guy, but I still negotiate with him and sometimes disagree with him on rights theory versus utilitarianism. So neither of us is necessarily right, because we've got a values dispute and a philosophical dispute, and the world continues, right? Because Mark and I don't always agree on everything, but he makes decisions in his world and I make decisions in mine. It's all about control. Politics is ultimately about, if, you know, Prime Minister Albanese says this is the way, my way or the highway, or President Trump does that. So it's all about power rather than intelligence, I think. What do you reckon, Tony?
I think that they're really good points, and that in the grand scheme of things, we can argue, or I would contend, that the single factor that has conveyed the greatest power to any group is intelligence.
Yeah.
Have a look at this image behind me. Look at how much we've modified this planet. We've done that not because we've got sharp claws or can run fast. It's because we are the preeminent intelligent being. And I guess the extrapolation to the idea of an artificial super intelligence posing a risk to us, you know, arises from the same idea. It's that power imbalance. And it is hard to envisage. It's hard to envisage the incipient steps between now and an artificial superintelligence. What could that world look like? What would it have to look like for such a thing to exist? I think that it would need to have fundamentally different other supporting technologies in place, social structures, expectations, and a whole bunch of other things before we could get to that. But the worry about it is that simply as we stand in relation to, you know, less intelligent biological entities right now, it's not that we, you know, wish them any malice. It's that if our goals conflict with theirs, we prevail, often at their expense. And that's really the risk of a vastly superior intelligence living in our midst.
And the slight advantage we've got over the other intelligent forms of intelligence is our communication skills. So we can kind of liaise with other human beings and other nation states and work out what's supposedly in our best interests. But are you suggesting perhaps that the power of persuasion becomes part of the social tools or the socio-technical solutions that superintelligence harnesses? So we all become, hackable and persuadable, and we all, kowtow to the great intelligence.
I think we agreed earlier that we probably are collectively hackable, and there's plenty of good writing about, and again, Tigmark's Life 3.0 outlines a number of scenarios along those lines about, how people could be influenced. But it's easy for us to extrapolate not too far into the future based on recent experience, as I've suggested with social media, to see how various groups in the population have been influenced en masse in various ways, to buy things or to behave in certain ways or to vote in certain ways. So it doesn't seem a difficult leap for me to imagine a world in which a sophisticated, beyond human level AI could avail itself of social media platforms, of infrastructure, of governmental functions, of a whole bunch of other elements at scale in the system to have large effects on people, populations.
Very afraid. Thank you. Les.
Just building on the discussion we're having about this, I'm inclined to think before we get to the problem of a super AI's goals and objectives conflicting with us humans, the earlier problem, I think, is that different human groups have different goals and objectives, and these different groups are going to use their own local AIs, AGIs, even super AIs to further their own interests. So I think, so you were talking, Tony, about one of the problems is getting the AI to conform with our own values. But the problem is, beyond the base agreement that we all have, which is furthering the interests of our own in-group, whether it's people in our own religion, people in our own state, our own nation, even our own gender. Beyond that, there are different ethical systems, and I've got 3 examples here. So what are we going to feed into the AI as a moral algorithm? One divergence is those people who think that the principle of freedom is more important than the principle of general welfare. That's one disagreement. Another one is people who think the principle of security is more important than the principle of privacy. And the last one is those people who think that the principle of prolonging life is more important than the principle of autonomy. So there's 3 divergent moral opinions. Which one of those are we going to feed into the AI as a moral algorithm? And that's only 3 of them. And that's why I think that in the interim, the earlier stage is going to be people using AI to further their own moral principles for their own benefit, for their own in-group. So, for example, a group of Ayn Randians, libertarians, using AI to somehow, we were talking about manipulating the general populace's opinion through social media. So that's one thing a libertarian group could do, spit out social media posts that promote the libertarian worldview. So I think that's the initial challenge that we're going to have with AI. Once we get, I don't even think we're going to get past that stage, let alone getting to the stage where the AI is going to conflict with some general agreed human moral schemata, because I don't think there is one.
I completely agree, Les. One little sort of reality check and reminder, none of this is guaranteed. It is speculative. And I would say that when I started looking at this in depth about 5 or 6 years ago, I was quite skeptical about the prospect of this ever occurring. It seemed firmly for me at the time in the realms of sci-fi. And yet, as time has passed, as the technology's progressed, as I've learnt more about it, I think I've joined not that I'm in the same league as them, but I've joined the majority of high-level AI experts in thinking it's increasingly likely that true AGI will at some point be produced. I see it as increasingly feasible. I can't really estimate when. I do have to take seriously the estimates of people more informed than I am, and as somebody who does spend a lot of time looking at risk and safety and probability, I find it prudent to start thinking about it and having conversations like this to come up with ways of both mitigating the risks and optimizing the potential, accrual of the benefits. Sci-fi has a lot of great responses to what you just outlined, Les, differing values. So enclaves. So I think William Gibson, possibly Neil Stevenson, and more recently again, Max Tegmark have all outlined in their writings a world in which, there are prominent AGIs and people sort of gravitate into values-based enclaves based on some of the things that you just described. And there'll be an enclave who rejects the AI. It's got no part in their lives, and they're all like Amish people, growing their own food and rejecting technology. There are other people who quickly rush out and get their Neuralink implant and upload themselves to the web and, inhabit their consciousness into a spacecraft that goes up for 1,000 years to somewhere else, etc. And people get to choose. Interestingly, actually, I saw a reasonably simple and practical proposal this week for a base level starting point for regulating AI, which is to require producers of generative AI systems to disclose, even though the systems are opaque and we can't know what's going on within them, we can ask them to tell us what data it was trained on. So users can then choose not to use the AI that was trained on the Proud Boys manifesto. And so that's one way of sort of starting to, and again, it's at a higher system level. It comes up from that inner substrate of perceptrons and the like, but it allows us to actually exercise some freedom of choice about how we interact with these systems. I can only see that working for a little while though.
Yeah, thank you. So this is actually going to what you were just talking about, Tony, about becoming interested in this like 5 years ago, but starting out as a skeptic and kind of moving on the scale. Yeah. And to that sense, I'm wondering, like, everybody here is interested in this technology and the future, but I think a lot of other people are not aware of it. And part of it is not understanding. Part of it is just not caring, like with a lot of political issues, until it affects somebody. A lot of times they'll try to ignore it. And so we've had sci-fi stories for so many years. Still, people can't relate those things to something that could actually happen. It seems a lot of times humans are motivated by kind of the trial and error method, and that works a lot for a lot of things, but it doesn't work for existential crisis because you only have kind of one try for some of them. And so the idea about like what would be the catalyst that got people to understand that things could be different with AI? Like, is it a physical, like a humanoid robot that they have to see before they go like, oh, this could be dangerous? Or because things like, and you talked about before, like the most kind of subtle, if the AGI starts to have its own intentions and it pretends not to, but it like starts a company, makes money, affects political elections, like all those are really subtle, abstract things that it's hard to kind of show people. But like for atomic weapons, like a lot of people had to see the damage it could do before they said, hey, this is different. Like we should treat this thing differently. Is there anything you think that would be the best thing to change the most amount of people's minds on this?
It's a really important question. It's a good one to finish on. And I do think of it like the frog in the slowly heating pot of water that just, we accept incremental change. We don't react much. We get up, we go to work, we eat dinner and go to sleep. We do our things individually. And we hope most of the time that they will fix it, whatever it is, and that the sun will rise tomorrow and everything will go on as it has, to be brutally honest, my feeling is that it would take some catastrophic event that was generated by or seen to be generated by a powerful AI system that would generate the sort of attention that you're talking about. So even with we've got humanoid robots. Boston Dynamics' Atlas robot is reasonably humanoid. It is incredibly competent. It can dance. It can backflip. It can there's a recent video of a worker working on a scaffold, and he drops his tool bag, and Atlas goes and retrieves it for him and does a couple of backflips on the way to accurately returning it to him. So we've sort of got some of that stuff, and because it's incremental, people just accept it in little chunks. So I do really feel that some sort of catastrophic adverse event, even the launch of a really humanoid-looking robot that can speak and talk and act like a person, I think that won't be ever sort of launched out of the blue. It would be an incremental thing after, mechanisms like Atlas just slowly evolve, and we'll be used to it. I don't think we've evolved, as you say, to deal proactively with things that are coming at us from the future. We are more reactive than proactive, unfortunately. But the more people talk about it, the more conversations like this that happen, I think the healthier it is. I'd encourage everyone. I'm really glad that Akiva and Les and Usha, that you're recording this, and maybe other people will see our discussion and they'll start reading and thinking about it and taking action, talking to their members of parliament, talking to people at work, and just raising awareness. And collectively, we are pretty clever. We are the super intelligence at the moment. We still are. There's 8 billion of us. We should be able to do something about it. That last little sort of provoking question on my philosophical implications slide was, are we God? And then there was the converse question, would this thing be God? Are we giving birth to God? Well, all that aside, we are collectively extremely powerful if we can create something that even sparks a conversation like this. So as I suggested to our, forgotten his name, unfortunately, our 23-year-old commenter before, be optimistic. We are incredibly powerful, and we should use that power, I'd say.
I think the level of interaction and questions and discussion we got tonight from all of our participants here is a real indicator of how much everyone's appreciated your talk tonight, Tony, and the ongoing and the discussion as well. It's been terrific.
Oh, it's been my absolute pleasure. Thank you for the opportunity.
Thank you.
To access other videos and podcasts in this series, go to the Philosophy Resources section of the Rational Realm website at www.rationalrealm.com.